Hello, everyone, and welcome to episode 8. In episode 8, we are going to be talking about decimal numbers. And in part 1, we are going to be talking about what decimal numbers are, what physical quantities they can be used to represent, and how to compare the sizes of two decimal numbers, whether they're positive or negative. Now, a decimal number is identified by a period in the middle of the number called the decimal point. So, for example, a decimal number might look something like this: 51.24. This dot in the middle of the number is what is referred to as the decimal point. Now, when you are writing a number, a decimal number like this one, these digits have different meaning depending on their position in the number relative to the decimal point. And the meaning of the digits, based on their position relative to the decimal point, is given by a chart that looks like this one. If you have the decimal point and you look at the number directly to the left of that decimal point, this is telling you how many ones are in your number. 2 steps to the left of the decimal point is telling you how many tens you have in your number. 3 to the left of the decimal point is telling you how many hundreds you have, then how many thousands, how many 10,000s, and etc. If you move to the right of the decimal point, for example, directly to the right of the decimal point, how many tenths we have. The number two spaces to the right of the decimal point is telling me how many hundredths we have. The number 3 spaces to the right of the decimal point is telling me how many thousands we have. And so the significance of these numbers is getting smaller and smaller as we move to the right of the decimal point. So for example, in the number 51.24, this number is telling me that I have 5 tens, I have 1 1, I have 2 copies of 1/10, and I have 4 copies of 1/100th. So this number, 51.24, would be the same as if I took 5 of 10 and combine that with 1 of 1 and combine that with 2 of 1/10 and combine that with 4 of 1/100th. This number would be equivalent to what we have written down, 51.24. Now, many of us, I think, are familiar with decimals from our work with money, because when we're working with money, the numbers to the left of the decimal point usually represent full dollars, and the numbers to the right of the decimal point usually represent fractions of a dollar, or what we would call cents. So, for example, if I had the number 257.63 representing an amount of money, this would be 200s of dollars, as well as 5 tens of dollars, as well as 7 ones of dollars, as well as 6 tenths of a dollar, in other words, dimes, if you remember actual coins from when we used to use coins, as well as 3/100ths of a dollar, which are represented using the coin called a penny. Now, when we are looking at two decimal numbers, and we're trying to figure out which one of these decimal numbers is larger, it can be useful to keep this money idea in mind. For example, if someone said, I have 7.3 versus 7.4, which of these two numbers is bigger? I just have to think about if I had $7.30 versus if I had $7.40, in which situation would I have the most money? If I had $7.40, I would have more money than $7.30. So this would be the bigger number, And if I were going to compare them using the inequality symbols, then I would put the mouth of the inequality toward the larger value. The mouth will seek out the better situation, the larger, the more positive number. Now, another way to look at this question, another way to compare the size of two decimal numbers, is to line the two numbers up so that the decimal place is in the same location for both values. And then to compare these numbers from left to right. We remember that for a decimal number, the value that's furthest to the left has the greatest significance, the greatest weight, and the greatest value. Now, in this first position, the two digits match. And if I move then one space to the right from that, the digit in the tenths position, 4, is the larger value. So because in this number we had the larger value in the tenths position, the 7.4 was the largest number overall. I can take either of these same approaches if I were comparing, for example, 21.01 and 21.1. The first way that I could approach this problem is I could ask myself, if I had this amount of money, $21.01, versus if I had this amount of money, $21.10, in which situation would I have more cash? Well, thinking about this financially, I'm definitely going to have more cash if I have $21.10 versus if I had $21 and only 1 cent. So 21.1 is just a little bit larger than 21.01. Alternatively, I could write these two numbers so that their decimal points are lined up. And then I can go through these numbers from left to right, comparing the digits one by one. Now the first two digits match, the second two digits match, but in the next position, this second number has a higher value in the tenths place than the first number does. So because this one has a bigger number in the tenths place, 21.1 will be bigger overall. And similarly, if we were comparing 21.1 to 21.09, I could think about it financially, or I could write the two numbers so that their decimal points were lined up. And when the decimal points are lined up, I can go through from left to right, and I can compare the digits one by one. The 2's match up, the 1's match up, but in the tenths place, the digit 1 is higher than the digit 0. And as a result, because I had a bigger digit in the tenths place, 21.1 would be the larger number overall. Because even though this 9 is a really big digit, that 9 is further to the right than the 1 is. And the numbers that are further to the right have less weight and less impact than the numbers that are further to the left. Now, let's talk about how we compare decimal numbers in the case that maybe one of those numbers is negative. So first of all, if someone asked me to compare the numbers 14.3 versus 14.1, then in this situation, I could just line up the two numbers so that the decimal points were in the same position, and then I could compare the digits one by one, going from the left to the right. They have the same number of tens, they have the same number of ones, but the number of tenths is different. This first value has 3 tenths, whereas the second value only has 1 tenth. And so this number, having the larger amount of tenths, would be the larger number overall. And the alligator mouth would point toward that larger value. However, suppose that instead of comparing positive 14.3 and positive 14.1, suppose that we were comparing the negative version of those two values. Remember that when we are comparing numbers, The alligator mouth is looking for the warmer or the better or the more positive number. So even though 14.3 is bigger than 14.1, because they have minus signs attached, negative 14.3 is more negative than negative 14.1. So the alligator mouth is going to seek out the other number. In this case, the alligator mouth is going to seek out negative 14.1 because negative 14.1 is more positive than negative 14.3. Negative 14.3 is more negative, so the mouth will move away from that value. Put another way, let's think about these values in terms of two different debts. Suppose that one person owes $14.30 and the other person owes $14.10. Who is in the better situation? The person who's in the slightly better situation is the guy who only owes $14.10, the guy who owes less. And so the alligator mouth, the mouth of this inequality, will point toward the guy who owes less money and is in a better situation. Now, if you are comparing two decimal numbers and only one of them is negative, then this is a really easy problem that you can answer very quickly. Because the alligator's mouth only always points toward the warmer number, always points toward the better situation, the alligator's mouth will always point toward the positive number, not the negative number, because the alligator likes hot food, and we would prefer to have $14.30 rather than owing $14.10. The mouth will point toward the better and the more positive value. Now let's take this idea one step further. We have a collection here of 1, 2, 3, 4, 5, 6, 7, 8 numbers. Some of them are positive, some of them are negative. So let's sort them from the most negative over here on the left side to the most positive over here on the right side. Let's write these numbers in order. Now the first thing that I'm going to do is I'm just going to separate out the negative values from the positive values. All the negative values will go on the left, and all the positive values will go on the right. So I'll do a little switcheroo, but the positive numbers, which are going to be the biggest ones, furthest to the right, and the negative numbers will be over here on the left side. Now, to finish sorting these values, all that I'm going to do is compare the numbers within these two categories. I'm going to say between negative 12.07, negative 12.7, and negative 20, which one of those is the most negative and which one of those is the least negative. I'll sort those. And then separately, I will sort the positive values. So I will sort 13.01, 13.1, 13.0001, 11.5, and 3.1. Now, starting with the positive values, remember that the digits that are furthest to the left have the greatest impact. Now, in the first number, we have 110. In the second number, we also have 110. In the third number, we have 110. And in the fourth number, we also have 110. However, in the fifth number, we have no tens. We have nothing in the tens position. So this number at the bottom, 3.1, is definitely going to be the smallest of the positive numbers. Now that I've compared the digits that are furthest to the left of the decimal point, let me compare the digits in the ones position. In the first number, I have 3 ones. In the second number, I have 3 ones. In the third number, 3 ones. In the fourth number, I only have 1 1. So because this value has the smaller number of ones, this would be the next smallest out of the positive values. Okay, now let's compare the values after the decimal point. The values after the decimal point, here I have 0 tenths. In the third number, I have 0 tenths. But in the second number, I have 1 tenth, which is the highest digit of those 3. And so this number in the second position is going to be the largest number in this list. Finally, to compare between these two values in the middle, 13.01 and 13.0001, I can now compare the digits in the hundredths position. The first number has 1 hundredth, but the third number does not have any hundredths. So in this situation, my value 13.01 would be larger than 13.0001. And so this would be the sorting of the positive decimal numbers in the list. Now to sort out the negative numbers in the list, I will need to think about which one of these numbers is the most negative. The one that's the most negative would go all the way on the left side of the list. Now, if I compare the digits in the tens position, the one with the largest number of tens is the third number in this list, negative 20. So this one is going to be the largest negative number. This one is going to be the most negative, the worst number in some sense. So it's going to go all the way on the left end. After that, the next sort of worst number, if I compare the ones and then compare the tenths, I have a 7 in this tenths position, and so this would be the higher of the two digits, and so this number is more negative than 12.07 is. And so being more negative, it will go further to the left when I sort. Finally, I'm left with the value negative 12.07, which is the least negative of all my numbers. And this completes my sorting. This is how we will sort decimal numbers that are both positive and negative.